Okay, next. Okay, I forgot to mention one thing, right? Uh, Around HF, around ammonia, how many hydrogen bonds are there? Right? How many hydrogen bonds? Four hydrogen bonds, right? Four hydrogen bonds, right? Around ammonia, there are four hydrogen bonds. Okay, especially, particularly, okay, have a look at this lone pair. Right? That lone pair form one because one lone pair will form one hydrogen bond. Right? Normally bonds are formed between a delta plus and lone pair. Right? Secondary attractions are formed between the lone pair and delta plus. Can you see a relationship between dative bond and secondary interaction? There's a relationship. First thing, the dative bond is a primary attraction, right? Dative bond is primary attraction. What's the difference? Dative bond means what? What's the relationship? Is it what common thing between dative bond and secondary attraction? It's a good relationship. Okay, dative bond is formed between a lone pair, for example, NH3, lone pair, and vacant orbital BF3. Okay, BF3. You know, boron in BF3, there's an empty orbital in boron. So this lone pair is completely given to not completely, partially. Is it? Partially. This lone pair is given to boron. And what's the result? A covalent bond is formed, right? Or a primary bond is formed. Right? Okay, between this lone pair and empty orbital. Got it? Complete empty orbital. What about secondary interaction? It's also between lone pair and HF. Lone pair and another HF. What's this? Delta plus delta minus. BF3 is an electron deficient compound, especially boron atom is electron deficient. It has an empty orbital, complete empty orbital. But here there is no complete empty orbital, delta plus partial empty orbital. Electron density is it's less. Electron density is less. Okay, partial empty orbital. That's why the bond is what? Secondary interaction. If this is completely electron deficient, with a complete empty orbital, then the primary bond is formed, that is dative bond. Here only partial bond is formed. This boron and this hydrogen, compare these two. Boron has a complete or perfect empty orbital, but here hydrogen, partial empty orbital, right? Okay, hydrogen atom has what? Oneness orbital, oneness orbital, and that orbital is now what? Little bit less concentrated because of the electronegativity difference. Fluorine pulls that electron density towards itself. So the electron density in hydrogen decreases. So a partial empty orbital, not complete empty orbital, partial empty orbital, then secondary bond will be formed. Right? Okay. Nearly same. Nearly same. Okay. Next. And then here, ammonia and water. How many lone pairs are there? 2 lone pairs. And both lone pair will form hydrogen bonds. Right? So totally how many hydrogen bonds are there around water? 4 hydrogen bonds because these hydrogens also. And what about HF? HF. Around hydrogen, how many lone pairs? Sorry, around fluorine, how many lone pairs are there? 3 lone pairs. So how many hydrogen bonds? Yeah, you can expect 3 hydrogen bonds. 1 lone pair, so 1 hydrogen bond. 2 lone pairs, so 2 hydrogen bond. 3 lone pairs, so you can expect 3 hydrogen bond. But it's not real, right? Only 1 hydrogen bond will be formed. Should be linear. Should be linear. Why it is? Why only 1 lone pair? Sorry, 1 hydrogen bond. Even though it has 3 lone pairs, why only 1 hydrogen bond? Right? Okay, you should remember that. How many dipoles are here? How many bond dipoles? 2 bond dipoles. OH, OH, 2 dipoles. How many dipoles are here? 3 dipoles. There only 1 dipole. Right? 1 dipole bond. Bond dipole. Right? Only 1. So you should remember that lone pairs will form hydrogen bond depends on the number of dipoles. Number of bond. Right? Lone pairs will form bond, but it depends on the number of dipoles also. Here only 1 lone pair, so it will form only 1 bond. No problem, right? It will form only 1 bond. There is no problem in NH3, but see that water molecule. How many lone pairs are there? 2 lone pairs. So can it form 2 or 1? It's a problem. 2 hydrogen bond or 1 hydrogen bond. It's a problem. You have to think about it. Yeah, of course. How many hydrogen bond? 2 hydrogen bond. Both lone pair will form hydrogen bond. Why? How many dipole bonds? 2. It also, these number of bonds, OH, number of dipole, number of dipole or number of hydrogen bond donor, just dipole, number of dipole, right? It also determines the factor. Right? There are 2 dipoles, right? 2 dipoles, OH, another OH, 2 dipoles. So the number of hydrogen bond, maximum number of hydrogen bond will be. See, how many dipoles are here? How many bond dipoles? 3. So maximum number of hydrogen bonds are 3. But number of lone pair is the limiting factor. Only 1 lone pairs are here. Only 1 lone pair is here. So maximum 3, but lone pair is only 1. So 1 bond. Here 2 dipoles. So maximum number of hydrogen bond is 2. Yeah, it has 2 lone pairs. So okay, it can form only one dipole. So maximum number of hydrogen bond only one. Right? 3 lone pair, but only one lone pair will form hydrogen bond. Got it? Okay. Let's see an interesting example. CH3OH. CH3OH. It's an alcohol. It's the simplest alcohol. It's called methanol. Methanol. This is one CH3 CH2OH. This is also an alcohol. Ethanol. Right? Ethanol. This is the alcohol. Normally, someone drinks. Right? Okay. This is the alcohol. Right? These are not these. Other alcohol, there are many more alcohol. Only one carbon. Right? A single carbon alcohol is methanol. 2 carbon alcohol, ethanol, propanol, butanol, pentanol, hexanol. There are many more alcohol. Even there's a famous alcohol, cholesterol. Cholesterol is also a type of alcohol. Right? Okay. Got it. Can you say this alcohol can form hydrogen bond between themselves or not? Yeah, it can form hydrogen bonds because OH. OH is what? It's a hydrogen bond forming dipole. What about this? CO. Is it a dipole? Yes. Electronegativity difference, delta plus delta minus is also. Both bonds are OH and CO. Both bonds are dipoles. So how many dipole attraction, maximum dipole attraction around this oxygen? Around this oxygen, how many maximum dipole attraction? Tell me. Yeah, it's comparable with water. HOH, HOC. Then H and C is the difference, right? How many maximum number of dipole attraction it can form? 2, because there are 2 dipoles around oxygen. Okay, so it can form 2 dipole attraction. But only one is hydrogen bond and the other one is normal dipole attraction. Got it? Why? OH. This is responsible for the hydrogen bond and this one CO. So only one hydrogen bond. One is hydrogen bond and other one is dipole attraction. Right? One is hydrogen bond and other one is normal dipole attraction. Okay. Got it? Yes, that's all. If you want, note it down or separate it.